Okay, I'm going to talk now about the intelligent document management product. We tried to build in the last year together with my teammates. I am the head of product strategy in Aramix, and this is one of the first complete products we set up, and we are now applying in real context. So it's been a very interesting journey. It's been, I'm technical myself, so I like a lot of the technicalities behind it, and I hope you like them too. So first of all, why IDM matters? The process of handling documents is costly, effort intensive, and error prone because traditionally the organization do it by hand. So basically they have lots of people that read the documents, extract the information, do data entry on the data sets. Okay, sorry. and they make errors. They cannot check for example, completeness of the documents, and they cannot, for example, look for different kind of errors, for example, lack of some informations. So there are lots of our clients that need to automate this process to avoid people do jobs that do not have any real value except for data entry in the system. So from documents to structured data is what they actually want. So basically they want to extract and parse, I don't know, tax files or payments, and they want to extract only some kind of information from those files, verify the content, and insert it in their databases. So the ultimate goal is to reduce the job for the effort for the people who do that job, and to save money, obviously, and time. So the business needs are to reduce management costs, reduce errors, and the one I already mentioned. And what we can do for them is to automate the tasks, eliminate the human error, or at least reducing it, improve the output form in the sense that the output is already structured in the form that they want instead of needing, intermediate passages between the human reading and the final database. It also enables some automated monitoring, so for checking and things like that. And most importantly, the data is deleted from the system. So the system is secure from their point of view. So many of our clients do actually have serious concern about security because they are processing personal data potentially, and they need to guarantee the security, that the data are handled securely. So this is the solution we implemented in the last year, in the last few months. And now let's go to the technical and more interesting part. So first of all, I think that it's relevant to highlight the architecture we used because we work on the Google Cloud platform, and we leverage different of their systems and their tools to achieve our goal. The architecture is actually indeed quite simple in the sense that we are using just a few tools from their side. We use the storage as a point of contact between their systems, their input docs, and our own analytics. We use Bitbucket because we have it in-house already, so we have a contract with them, but any kind of repository holder is fine. We automated the continuous integrations and deployment tasks using the cloud built in Google, and we built a series of, actually it's a real pipeline of services built on, hosted on Cloud Run, on the Cloud Run service, which perform the various steps of our process. So the first one is a loader. You have to upload the files. Then you split the files in single page images. You identify the single pages according to the document type you have to check. So basically, I don't know, if you know that a file is composed by a document ID, a and a text file altogether, you have to recognize for every single page, because they can be, in general, they can be scanned. So you have to identify for every single page to which documents it actually pertains. So you have probably many times the pages are not even ordered. So you can have the front side of the ID in the first page, then you have the text document, then you have the back side of the ID in the middle of the text document, then you go on with the text document. So the situation is like that. And so you have to split the page, identify each page to which documents it belongs, and then is the analytics part. So you have to clean the image. You have to extract the values you want for every kind of document. You aggregate back the informations for each document after you processed every single page of the document. You validate the information, so you perform the checks, anti-fraud or completeness checks you want to do, and then you format the output to return it to the next system, basically. The next system can be a database, an ERP, or any other system, basically, that can handle an API, so a JSON file returned by our REST APIs, basically. How did we structure the code? We tried to structure the code following the hexagonal architecture because these allow us a very clean and replicable structure for every single service. So basically, every service is structured like that. The hexagonal architecture, for those of you who are not familiar with that, is also called ports and adapters, and basically is structured so that every single bit, so port or adapter, can be changed and can be replaced by something else which has the same signature with the least cost as possible. So you can, as you can see from the figure, you have basically two sides. The driving side, so basically the input part, and the driven side, so what stands behind you after your system. Okay, and in the core, there is the logic. This kind of architecture allows you to abstract the logic, the domain logic, from the connectors. So on the input side, you get informations through the adapters which communicate to your port. And you can see basically this part as a fast API application, as a microservice that exposes a few, in general one endpoint, receives the informations, and then process, and then there is the next part of the service, the domain logic, that implements the logics that should be typical of this specific service. And then the output part implements those logics and returns the result. So in case you want to change the logic, or sorry, not the logic. In case you want to change the input or the output, you just can change those implementations, keeping the logic safe, because in general, the logic is what you want to keep stable. You don't, once you define that something is, I don't know, a loader, it should load things. You should not do that, anything different. So you can say, okay, I want to load things from Google Cloud Storage. I want to load them from, I don't know, another kind of database, another kind of storage. Okay, you just change the port, the input port in this case. But what you do beneath is the same. And in particular, what you do on the other side. So what you give to the next system is still the same. And this allowed us to be quite a lot flexible, actually, in terms of how our clients can interact with us, because they can say, okay, I can put my data on the Google Cloud Storage, but I can say, okay, I can't put the data on the storage because of my own policies. Then you have to connect to my database, or I have to call your API to give you the documents directly. For example, if they want to do real-time processing. They don't want to upload on storage and then start the processing. The storage is thought for a batch execution. If they want real-time or near real-time execution, they have to call directly the API of the first service, the loader. So basically, we set up actually two different ports with the relevant adapters. One for the real-time execution, for which the client can directly post the document, the image. And on the other side, we also create a batch port to load a batch of information from the Google Cloud Storage or from wherever, and pass it to the domain and go on. So this is why we choose this kind of architecture, and this is why it worked very good for us. In terms of actual implementation, how we actually implemented that architecture in Python, in terms of Python modules, those are actually Python modules. Every one of our services, and you will see quite a few slides with the same schema because they are all the same in terms of architecture, we implemented 4 basic modules. A microservice module, which represents the input adapters and ports. So it's the driving side adapters, basically. The logic module, which represents the domain logic and actually contains all the base classes and the abstractions we need for the logic to work. The adapters module, which represents the driven side adapters and ports. So basically, it represents the output part and actually implements the logic defined in the previous step in the concrete cases they need. And then there is an example. So actually, there is an example module which is different for every client because it's their own implementation. So how do they want to implement the whole service for their cases? Obviously, it's not different every time because there are lots of things in common, but in general, it could be like that. So I go now through the services, but I mean, the slides graphically won't be very different between one another, but because the structure is always the same. The real point is what they do. So I'll go deeper in what they actually do inside. So we will always have a microservice, which actually takes the name of the module, so loader microservice, cleaner microservice, etc., and implements the ports, so the endpoints, the post endpoints that should be called to activate to trigger, in this case, to trigger the service. So as I mentioned before, for the loader, we have 2 different endpoints. One to upload a base64 file, and the other one to upload a batch of files. The logic module, in this case, implements a service. What actually is it doesn't implement. It defines a service. It's a bit different. So it defines what the service actually do. So this describes the business logic of this microservice. And in this case, it creates, it takes a named list of files and writes them on the Google Cloud Storage. So allows the user to upload the files. The adapters module, which are, they are currently not implemented for this specific service because they don't need it. This file loads the files and writes them down. So in single or in batches. For what it takes is, what happened? Oops. It happened something there. That's weird. Okay, we're back. And for what it takes, the example, we implemented a fahad that registers the instance of a loader service and set up to write given a Google Cloud Storage bucket, and implements an example of the microservice itself. So basically, the example model still. Is it me? No, shouldn't be me. Please don't. Okay. Sorry? Oops. Should be fine. Okay. And basically, this is an example. So this is actually an example of the example. So this is how we implemented the microservice. The most relevant part is actually this one. So the implementation of the microservice is the most interesting one because it actually reads directly from a configuration file. So you can simply change how it works just changing a few strings from the configuration. in case it's easy. For what it takes, the next module, it's a splitter. So we have a file, and we split the pages. The structure is exactly the same as before. The service implements a split method in this case, which splits the pages. And now we have the adapters. And in particular, we have one specific adapter, which is called PDF to JPEG, which splits the PDF pages in the input file. Guess what? In PDF, in JPEGs. So, and in the end, basically, this is the facade we implemented in that case to be able. Nope.
Not me. Sorry.
Is that me?
No, it's the thing. You're signing out. Sorry.
No problem. As you can see in this case, I showed you the example of the facade we implemented. It handles both the repository, so the connections to the storage layer, and the service itself, configuring it how we want to use it. As always, the facade takes in input a configuration, so as mentioned before, it can simply switch what it does but just by changing the file. I'm switching. Okay, the next service is the Identifier. I will not go longer again in the steps of the modules, but the structure is always the same. This file, this service, sorry, identifies the images. So basically, this point is the most interesting part from a data science point of view until now, because it actually identifies the document a page belongs to. And so we implemented an object identifier, which is an object detector. So it's an implementation of a deep learning algorithm that is trained to identify specific details in the page to identify the document that the page belongs to. So I don't know, you can think about some kind of marks or watermarks on the back, or page numbers of some specific formats, or some specific also words in specific positions. And these allow us to identify the document each page belongs to. As you can see, the implementation of the identifier is quite easy, because it's based, everything is done by the object transformer class, which is a model, machine learning model, actually, deep learning in this case, but which takes some data, some image, JPEG, and returns the document it belongs to. We have a different model for every document to be able to recognize. They are all binary models, so is that model or it's not. The training of this model is quite easy and cheap, in the sense that it's cheap from a computational point of view, but it's also cheap in terms of time, because those are quite simple models, because you are just, you just need to identify the marks that identify the model, the document, sorry, and you have to train an object detector model, so you have to fine-tune it, actually, because it's a deep neural network, pre-trained, usually, and to identify it. So it's easy. It's something that you can do with a few shots learning. For what it takes, the next step, it's a cleaner. So you clean the images before the extraction of the data. The identification can work on, raw images, not so clean, because it just has to identify a few marks. The next step, the one in which you extract the data from the document, it doesn't. So basically, you have to clean and pre-process the documents. So this is actually the clue of this step, in which we use services offered by Google, the Vision API services, and to perform the cleaning, because it's, very efficient and very good in terms of final results. And for what it takes, the extractor, which is the other part which is relevant from a data science point of view, and it's basically the clue of the application. The structure is always the same as I mentioned before, but what we do in this case is to implement an object OCR extractor. So the idea of our application is to implement a pipeline of object detection and OCR after the object detection. I can say directly that the OCR part is left to the Google services. So we are using the Google Vision API to extract the text, but the object detection is the point, and it's the characteristic of this process, because we are using a different deep learning algorithm to identify specific portions of the images. In this case, the training is a little bit more costly. It's still something that can be done with a few labeled data, but it still needs labeled data. And it requires us to label the portion of the page that we need the data from, and we need also to check the value so that we can evaluate also the OCR part. And at this point, we have this implementation of the object OCR extractor, so of the adapters, which relies, as before, on a few models, because we have a single model object OCR transformer for every document type. We also tried to be document agnostic, but the result was quite bad in terms of performances, because what you can extract without relying enough on the structure of the document was quite bad in general. Even if the quality of the image was good enough, the result without relying on the structure and the layout of the document was not that good. So we had to implement a different set of models for every different type of document, and we perform the transformation, so we apply them here. And as always, there is a facade in the example which handles how the process is done by configuration file. And after the extractor, there is the aggregation, because we have, until now we processed every single page by itself, but we need to group the results together for every kind of document, both because, it's what our clients want, and both because if we want to perform consistency checks on the document, we have to have the whole data together. So we implement this aggregator service with a default aggregator adapter, because it's quite basic, so we use the same adapter for everyone, which does this thing. It actually aggregates, it reads the files, the processed files, and aggregates the data together. And this is another quite relevant part of the process. Even if until now it's not artificial intelligence driven, this part, so machine learning driven, it's deterministic, but it's quite relevant for the final result, because in this step we perform the validations. So basically we check a set of rules, a set of controls that our clients want to check. So for example, they want to check if all the documents in a file are relevant for the same person. So the name is always the same. So we have to check the names and surname. Another client wants to check if any given person, so person cited in the files, is into a blacklist for, I don't know, in general it's credit in this case, but in that specific case it's an internal blacklist for spammers. But, and they want to see if this one is blacklisted. So basically if they have to check for alerts and warnings. And this is something that it was done by hand after months after the data entry. So they had months to perpetrate the fraud, let's say, in general. In this case, it's something that should be automatic, because we just read the blacklist, we integrate the blacklist in this service, and it's done. And so we create an adapter that takes the data from the blacklist. We implement it in our logic. We implement a service that performs that, and we implement an output adapter that does that based on the rules of the service, and then we return the results already processed. And here, that control was quite big, so I couldn't include it in a slide, but I implemented a quite easier verify, so it actually counts the files. So how many, the name is not actually correct, how many documents we have in a single file. The name is quite misleading, the name of the class. But, so we want to check that the file is complete. There is the correct number of documents. And this is the check. So that in this specific case, what happens is that if the document is not completed, we give the result finally, and then the system behind us actually goes back to the client and asks, okay, complete the file, please. So we have to run it again. And finally, in the end, there is the output formatter. So we simply structure together and finish the loop. And that's it. Okay. Thank you very much for your attention.
Thank you so much for your talk. Okay. I think we have some questions. Let me check. Do you implement semantic in the acquisition? Sorry.
Yes and no. I mean, upon request, in the sense that it depends on very much on the use case. But usually we do, but it's not something mandatory.
How many documents do you need to train the extractor on a specific type, shape of a document?
I mean, as of now, we use in the hordes of a few hundred, so 200 in general. But we are working on that to reduce very much the number of documents necessary to do that. We are working on trying to apply in a few shots learning also in that case, but it's a bit different than for the identifier.
Do you work with handwritten documents?
I mean, that's a very tricky question because the answer is it depends. In some cases, yes, we do. In others, we don't. The main problems with handwritten documents is that if the document has a format, the unwritten version usually are unreadable in the sense that the human doesn't respect the form. So this is very hard to read the information from that forms. In other cases, if you have to read something which is unwritten in a very specific point, for example, a sign or something like that, or something which is quite regular in terms of the content, you can do that. In general, it's very hard to be able to be general with unwritten documents.
Okay, last question. Looking at the slide, it seems you apply DDD2. Have you had a productivity issue with new, less experienced developer approaching such an architecture?
Yes and no. I mean, sorry, I'm keep on answering yes and no, but that's the truth. With the really junior developers, we actually have issues because, I mean, fresh from the university, they never heard about it, and they had both the problems with the architecture structure and the problem with the development process. They have to learn how to develop. So when we onboarded two, basically, very young developers, they experienced some issues. So they take a few weeks to correctly understand everything, but they had problems not only with the architecture, they had problems with Git. So it's something a bit different. I'd say that the architecture wasn't helping them, for sure, but it was not the main problem. With more experienced developers that never saw the architecture before, I mean, we found some resistance, as usual, because they were used to work in other ways. But after a few days, in terms of days, they understand how the architecture worked. We already had the code structure, so basically the modules structured. So after they understood how a repository is structured, and they are all structured the same, they understood the value of that because they say, okay, oh, that's good, because all the abstractions are here, all the implementation are here. Whatever takes the input part is here, so basically it's easy, everything is there. And the signature, they were already used to have predefined signatures. So basically, they were not surprised that something should be signed in some way. And of course, we discussed about the signatures with them. So in general, I'd say it's been as painful as expected. So for the young people, it's hard, but for the older one, no, it's not.
I think we have to finish. Thank you. This was the last question. And now room change. So thank you very much.
You're welcome. Thank you.